Lesson 2.3, Task 3. Alright, find complex solutions using the quadratic formula. You can use completing the square to derive the quadratic formula. Rewrite the quadratic equation ax squared plus bx plus c equals 0 as ax squared plus bx equals negative c. And then divide both sides by a to get x squared plus b over ax equals negative c over a. From there you can complete the square. Alright, so this is in standard form. This is normally how we see a quadratic. And in order to use completing the square, they have to put it in the form that we've seen in the previous task. So that's why they subtracted c, and then we want x squared by itself, so they divided everything by a to get this form here. Okay? Alright, once you get this form here, you can see that they took the middle term, or this b term, and they halved it and squared it. And when they did that, they added that to both sides. So that's what completing the square is. Half it and square it. That way you put it as a perfect square trinomial so that you can then write it in factored form. Alright, so this is the factored form of this. And remember that they used additive property of equalities, so they had to add the same thing to both sides of the equation. That's why you see it here as well. Alright, then they're going to square everything inside the parentheses, so it becomes b squared over 4a squared. Alright, when you add or subtract a fraction, you have to have a common denominator. So you can see in the next step, they have to add 4a over 4a. Anything over itself is just 1. So they add 4a and 4a here in order to get a common denominator of 4a squared, so they can combine it here. Alright, so then you got b squared minus 4ac all over 4a squared, which is the common denominator. And then the next step would be to take the square root of both sides. If you take the square root of both sides, it disappears on the left, and it becomes plus or minus the square root of all of this on the right side. Alright, then you can see that the bottom is a perfect square. So you can leave the square root on the top in the numerator and take the square root of 4, which is 2, and the square root of a squared, which is a. And then the last step is going to be to subtract the b over 2a. So it's going to be subtract b plus or minus the square root of b squared minus 4ac. Since it had a common denominator of 2a, all of that gets put in this form, and you see the quadratic formula. Alright, so they started with just standard form, subtract c and divide it by a to put it in this form, and then completed the square to find the quadratic formula. So that was using completing the square in order to derive the quadratic formula. Now this is a formula that you need to commit to memory, because this is something that you will see often, even on the ACT. And they don't give you the formula, you're just expected to know how to use it. Okay? When using the quadratic formula, put the equation you are solving in standard form. That means from your highest exponent down. Then solve values to solve. So we have x squared plus 10 equals 2x. So you're going to subtract 2x from both sides. But because that's your linear term, that goes in the middle. So you've got a quadratic term, a linear term, and a constant term. This is in standard form. Okay, so it goes from your highest exponent down. So your exponent's 2, this exponent's 1, this one doesn't have an exponent. Alright, from here you could figure out that your a is 1. Your a comes from your quadratic term, b comes from the negative 2, the linear term, and c is 10, that comes from your constant term. So you're going to plug in the 1, negative 2, and 10 into the quadratic formula and simplify. When you do that, you get x equals negative 1 plus or minus 3i. So let's see if we can get the same answer here. So let's look. So we got x squared minus 2x plus 10 equals 0. We've got A equals 1, B equals -2, and C equals 10. So I know the quadratic formula. We just derive that. It's going to be -b plus or minus the square root b squared minus 4ac over 2a. So what we're going to do is substitute b in for the b's, substitute a and c in there, and simplify. So we're going to have negative b, so b is -2, so it's going to be a positive 2. Plus or minus square root of b squared. So it's going to be -2 squared minus 4 times 1 times 10 all over 2 times 1. Right, then we're going to simplify under the radical first. So -2 squared is 4. And then minus 1 times 10 is -40 over 2. So x equals 2 plus or minus. 4 minus 40 is minus 36. And that's all over 2. And that's going to be 6i because it's negative. And then this can be reduced. 2 divided by 2 is 1. Plus or minus 6 divided by 2 is 3i. Alright, somehow they went back to a negative. I think this is incorrect. So they did substitute a positive 2. So negative b. Negative 2 would make that a positive 2, which they started with, but then they went back and somehow got a -2 again. So they've just got a typo there, so don't worry about that. The correct answer should be x equals 1 plus or minus 3i. It says, how do you know which values to use for a, b, and c? A is the quadratic, b is the linear, c is the constant term. Alright, it says to check your solutions. Oh, they got back to the right answer down here. Alright, so check your solutions. They plugged it in. If you plug this in and square it, you're going to get 9i squared here. Well, you know you got to do a binomial times itself, so you have to do distributive property here. But when you do that, the one part you're going to get 9i squared, which would be -9 here. And then the middle term would be the 6i. So that simplifies to 2 plus 6i equals 2 plus 6i, which means the solution checks out. So that is all for, let's see, task 3. If you have any questions, let me know. Lesson 2.3, task 4. Identify whether or not solutions are real. The part of the quadratic formula inside the radical b squared minus 4ac is called the discriminant. You can use the discriminant to determine how many solutions a quadratic equation has. Alright, so this is very important. Using the discriminant of ax squared plus bx plus c equals 0. You can see they've put it in red here. This is the part under the square root, and this is the part that tells you whether it's real or imaginary. Remember, if it's under the square root and it's negative, then that becomes non-real solutions or imaginary solutions. So the discriminant is the important part of the quadratic formula here. So if the discriminant is greater than 0, you have 2 real solutions. If the discriminant equals 0, you have 1 real solution. And if the discriminant is less than 0 or negative, you have 0 real solutions and 2 non-real solutions. All right, it says a t-shirt manufacturing company profits can be modeled by the function P of X, where X is the number of t-shirts sold. Can the company's profit ever reach $90,000? All right, you can use the discriminant to analyze the company's profits by finding whether there are any real solutions of the equation for a given profit. So X equals the number of t-shirts sold. All right, so it says write an equation to represent the situation. To determine whether the company's profit can ever reach $90,000, substitute $90,000 for P of X. Then write the resulting equation in standard form. So if we substitute $90,000 here, then we subtract $90,000 to put it in standard form. That gives us our A, our B, and our C. We can then take that and find whether it's going to be, well, we can use the quadratic equation to solve, but we can first look at the discriminant to see if the answers are going to be real or imaginary. All right, so it says, why should you write it in standard form? It says identify the A, B, and C are easier when it's in standard form. All right, so it says find the discriminant. So we use A, B, and C from the equation right here. Okay, so we plugged in 90,000 for P of X, or our Y value, but then we subtracted, and that's how we got the 93,600 here for C. All right, so the discriminant is B squared minus 4AC. So we're going to do B squared, 125 squared, minus 4 times our A value here, times our C value here. Now, we got a negative number. That means that there are no real solutions and two non-real solutions, or two imaginary solutions. This means that the company cannot make a profit of $90,000 given the profit function. So that means with this equation, they're not going to make $90,000. What would a positive discriminant tell you about whether the company could make a given profit? If we got a positive number for the discriminant, that would tell you that the company could, in fact, reach $90,000 for a profit margin. Okay? All right, that's all for task 4. If you have any questions, let me know.